One of the uses of finding a z-score is to directly compare two quantities that might not come from the same distribution. So in part A, Benny and Aaron are on the same track team, and they've recently competed on track and field day, and they both won their events. Benny won the high jump with a jump of 75 inches, and Aaron won the 100-meter dash with a time of 12 seconds. Suppose that the jumps are normal with a mean of 65 and a standard deviation of 2, and that the dash is normal with a mean of 15 and a standard deviation of 1. We're wondering who performed better, Benny or Aaron. We cannot directly compare the jump of 75 inches to the 12-second mark, but what we can do is put them in terms of their respective distributions to see where they fall in that sense. And so we'll be finding a z-score for each of these. So for the first individual, Benny, to find the z-score, we take the observation and we subtract the mean and divide by the standard deviation. So the observation was 75, the mean is the 65, and the standard deviation is a 2. So we end up with a z-score of 5. When we look at Aaron's result, we have an observation of 12 seconds, the mean is 15, and the standard deviation is 1, so we get a z-score of -3. When we're talking about the jump, we want to be above the average, so it's good that there's a positive here. And then when we're talking about the 100-meter dash, we want to be faster or smaller time than average, so that's why we have a negative here. At 0, a z-score of 0 would be average, and so as we deviate from 0, that is more extreme. So as compared to a 0, which would be an average time that we'd get a z-score for, what we're seeing is that 5 is more extreme. And so in that sense, the answer to who performed better is Benny. In the second part, we have a car that gets 36 miles per gallon, a truck that gets 22, and we know that cars are on average 34 miles per gallon with a standard deviation of 5. Trucks are 19 miles per gallon on average with a standard deviation of 3. Which vehicle performs better relative to other vehicles in its class? Obviously, 36 is better than 22 for miles per gallon, but we're comparing two different vehicles. So for the car, the z-score will be the 36 minus the average of 35 divided by 4, so we get 0.25. For the truck, the z-score will be the observation of 22 minus the average of 19 divided by standard deviation of 3. And so for that, we get a z-score of 1. Both of these being positive means both of them are above average in their class. The one that is more extreme here is the 1. So the answer there is the truck does better relative to its class.